Welcome back to the morning show. Coming up on 6:50. It's Wednesday, and got a whole bunch of stuff on the table. That must mean it's chemistry time. Jesse Miller is back.
Right.
So we're talking about salt and water and all kinds of good, fun stuff today.
Well, that's right. I was my basement flooded.
Oh, geez.
Monday.
Sorry to hear that.
Yeah, 6 to 12 inches in the basement. So I got to thinking about water quite a bit, as you can imagine. So, you know, as things were floating around my basement, and just about everything, you know, some things float, some things don't float. My Xbox didn't float.
Oh, that's too bad.
You know. But I got to thinking about this. Now, water has some interesting properties. We're going to explore that all over the place. But one of the things, and I know you probably can't see this very well from the angle, but paper clips. Now, we talked about density last week, and this is much denser than water is, and it doesn't really have a surface area like a boat does, but water also has a property of surface tension. And it's kind of like a skin, if you want to think of it that way, on there. And if something is light enough, well, you've seen water striders, the little spiders that walk across water. It's the same thing. And if you can spread out your weight enough, and you can, I can do this like 3 out of 5 times. You can get those paper clips to float.
Fancy.
Okay, now, if you break up the surface tension, however, they will sink. And this is surfactant, it's soap.
Let's put this on the floor.
Okay.
That way we can see what we're talking about, because we lost our overhead camera, because we don't have that anymore. So we'll just do experiments right there.
All right, so we can see this now?
Al get us a good shot of there, and then we'll go back to what we're doing.
All right. So you can see, hopefully, that these paper clips are floating, maybe. Move the bug there. Okay, so the paper clips are floating. This is surfactant, and this will break up the surface tension on the top of the water, and it should cause these to sink. There you go.
Oh.
And they'll sink.
Interesting.
And, okay, so that's one thing, you know, surface tension. We're going to play a little surface tension here.
Okay.
This is a little boat that I made out of paper. Now, hopefully we can see this as well. Maybe we should put this on the floor.
Let's go.
Okay.
Just take the chemistry experiments to the floor today.
Whoa, and I'm spilling.
It's all right. We spill food in here all the time. Don't worry about it.
Apparently, my hands aren't as steady as they used to be. Okay. So I just made a little boat out of paper here.
Okay.
And got that floating. And the surface, if we break up the surface tension behind the boat, the surface tension of the water in front of the boat should pull it forward.
Oh, really?
And kids, you can do, you know, the kids can do this at home if they want to try it. And as you can see, it just scoots along there. Now, unfortunately, you can only do it once, because once you break up the surface tension, it doesn't go. Cool. Okay, so that's a little bit of surface tension. I'm going to show you something a little bit more interesting on the next segment. But this one, okay, water boils. Now, water boils because you put enough energy into the system, enough heat to cause the bonds to break, and then it turns to a gas. Now, it turns out that temperature is pressure related, because we have 5 miles of air above us, all pressing down on us at this point, 14.7 pounds per square inch. And that presses down on the water, and it raises that temperature, that boiling temperature up. So if we're able to reduce the pressure, okay, it should be easier, or the temperature, the boiling temperature should go down. Now, this is just water. Yeah? Okay.
Okay, so we trust you.
It's not hot water, right?
Yeah.
So I got a vacuum pump here, and I'm going to remove all the air out of not out of the room, but out of this. This will just take a few seconds. I know it's kind of noisy.
It's okay.
But as the pressure goes down on here, we should see it start to boil. And you can see the bubbles starting to form now. And we give it just a little bit more.
It's a lot faster than microwave.
Yeah, but unfortunately, now, if you're at high altitude, right, water boils at a lower temperature, so you have to cook things longer at that high temperature.
The recipe.
And this is right. And I don't know if you can see the bubbles in here forming. It is actually starting to boil. Okay, and just to prove to you that the temperature hasn't gone up. Okay.
It's boiling, but the temperature is the same.
Right, same temperature. It's just reducing the amount of pressure on top and reducing the temperature at which the water boils.
Very cool. All right. Well, there's segment 1. What are we talking about when we come back?
I'm going to actually show something real cool with, it has to do with, well, water freezes at a lower temperature if you put salt in it and stuff like that, right? And I have a bottle of Schweppes that we're going to super cool, and well, you'll see what happens.
Okay,
with it.
we don't want to get too much of it away, but if you want to see this segment again, our website, morning show, click under Chemist Corner. We're going to go with that name until we can think of a better one. Is that okay?
Works for me.
All right, Jesse Miller, we'll see you back in 30 minutes. Right now, we're checking with Jennifer Ketchmark.